All right, 2.8b. Okay, last lesson of the chapter. Here we go. We're going to stick with inequalities. We did polynomial inequalities. Now we're going to solve other inequalities. And by other, I have 3 different types of inequalities to solve. So it's going to work the same way, though. You're going to find the zeros. Also, you're going to find any undefined values of x, and then you're going to do a sign chart. You don't want to graph these because you don't know what these look like. Polynomials are nice and easy to graph, but we're going to make sign charts, okay? So here we go. This is what we're going to do. We're going to find the zeros. Okay. Also, any undefined values of x. Undefined values. So that's 2 things. First, find the zeros, then find the undefined values, and then we're going to make a sign chart. There we go. I almost write sing every time I write sign. Yeah. Our devotions this morning was about how God sings over us. It was really good. So, okay, anyways, let's go. Number 1. Oh, that's cool. Cool story, bro. All right. F of x is equal to?
Me and Jonah we could walk both.
No, I'm good. 2x plus 1?
It turned out so well.
No. Shh, I'm recording here. Okay. Over x plus 3 times x minus 1. All right, see that right there? You don't want to graph that if you don't have to. I don't want to graph it either. But you are going to have to graph some of these on your test, though. You will have like 1, I think. So this is what we're going to do. We're going to determine the zeros, any zeros of our rational function. Okay? B, we want to find our values that are undefined, our undefined values. And then C, we're going to find out where this polynomial is, let's do greater than or equal to 0. And then where this polynomial is not polynomial, it's a rational function, is less than or equal to 0. We're doing polynomials on Friday. Okay, that's a lot. Now, the first thing you want to do is you want to find anything that's going to be a critical point on this thing. So the first critical point would be, where's my 0? To find the 0, no, that's undefined. To find the 0, you want to let f of x equals 0 and solve. Negative 1/2. Okay, so letter A, x equals negative 1/2. Okay, that's going to be a critical point. It's a 0 of the function. Letter B, anything where x is undefined, that would be at? Perfect, negative 3 and 1. Okay, now we're going to make a sign chart with those 3 numbers. So draw yourself a nice, good sign chart. And my suggestion is this. At negative 3, put a circle around it because x can't be negative 3 ever. You can't include that in any of your answers. So negative 3 is not allowed. Negative 1/2 is a 0. So what I like to do is I like to put a dot there because I know that's 0. And then over here, positive 1 would be an open circle too because it's going to be undefined there. And let's make our sign chart. So here we go. We're going to choose numbers in each of these 4 intervals and plug them in. So over here, let's pick x equals negative 4. Okay? Now when I plug that in, I'm plugging it back into my original function. I don't care what the number is. I care what the sign is. Okay? So when I plug negative 4 into the numerator, I will get a negative up top. So I get negative 8 plus 1, that's negative. Negative 4 plus 3 is negative. Negative 4 minus 1 is negative. So what I end up getting is a negative over a positive, right? Because a negative times a negative is positive. I get a negative over a positive. So this interval is what? Negative. Good. Okay, let's test the next one. Pick a number between negative 3 and negative 1/2. Negative 2. Oh, that's what my other class picked too. All right, x equals negative 2. Plug it into the original function. Where is it? It's way up there. So it's negative 2 times 2 plus 1. That would give me a negative up top. Negative 2 plus 3 is a positive number. Negative 2 minus 1 is a negative. So for this one, I get a negative over negative, which is positive. All right, now pick a number between -1/2 and 1. 0. Wow, me too. All right, so plug that in. Get a positive over a positive times a negative. So that's going to be negative. And finally, let's plug in x equals 2. And we get positive, positive, positive. We're so positive. Alrighty, finally done. Okay, now let's answer the questions. Here we go. We are looking at our sign chart, and we're trying to just determine where this polynomial, so letter C, where is this polynomial? I keep saying polynomial. Where is this rational function greater than or equal to 0? So we're looking at all the positives, okay? So right here, we are greater than or equal to 0. So I'm going to say from -3 to -1/2 bracket. Okay, don't include -3. It's an undefined value of x. And then it's also positive from, no Kleenex? 1 to infinity. SAT was here. I thought I was crying. Did you want this? It's very soft. No, it's so soft. No?
Now teach.
All right, I'll have to bring some in again. Okay, there you go. And that's it. All right, so let's go to part D. Part D was where is this thing less than or equal to 0? So it's negative from -infinity till -3. Doesn't that help a lot to put those open circles on that graph just to remind you that don't pick that point, you know? And then also in here from include -1/2, but don't include 1. Okay, pretty good? Yeah, not too bad. All right, so that's our rational function. Now let's do a radical. We'll do a radical, something with a radical in it. So number 2. Number 2. Let's say that we're trying to find where x minus 3 times the square root of x plus 1 is greater than or equal to 0. Okay, for these other things other than polynomials, you don't want to graph them. You don't get your calculator for this part. You want to make a sign chart. So let's go ahead. First thing we're going to do is find out what's going to make this 0. Okay? These are just factors times each other. So 3 would make the whole thing 0, and what else? -1. Very good. 3 and -1 make it 0, right? If I plug in 3, the whole thing would be 0. If I plug in -1, the whole thing's 0. So let's go ahead, and that just splits it up into 3 intervals this time. A little bit easier. So -1 to 3, and put solid dots on those because that's where our function equals 0. There we go. And now we're going to test. Okay. So pick a point on this side. I would probably pick x equals -2. And if I plug this in, I get a negative times, undefined. Okay, so guess what? We don't have to test that interval because there's no x values over there. The whole thing's undefined on that side. Yay. Okay, now let's test in between -1 and 3. I would probably choose 0. And so when I plug in 0, I get a negative times a positive. So that would be negative in there. And then probably x equals 4, maybe. And that would be a positive times a positive. So that would be positive. All right. Not so tricky, huh? Except there's a little tricky part coming up. So when we answer the question, where is this polynomial greater than or equal to 0, we're looking for where it's positive or 0. Oh. So we have kind of a couple answers here. So I would say 3 to infinity, and then also -1. You can write it like that if you want to. You can write x equals -1. But don't forget that that's actually a solution to this too. So this is greater than or equal to 0 has to include the positive and the zeros. Okay? All right, one more. Last one. Number 3. Now let's do an absolute value. Let's do something that looks like this, something with an absolute value in it. X minus 2 over the absolute value of x plus 3. And we're going to find out where this is less than or equal to 0. Okay. All right, so we have 2 critical points here. What do you think they are? X equals 2 and negative 3. Okay? But they're different from one another. 2 is a 0, negative 3 is undefined. Okay, so when I go ahead and make my sign chart, I'm going to go to negative 3, and I'm going to put an open circle on negative 3 to remind myself not to have that in any of my answers. And then 2 is a 0, so we'll go ahead and color that in. All right, let's pick some numbers. I'll probably choose x equals negative 4. And so when I plug negative 4 into this function, I get a negative over a positive. The bottom's always positive. And so that gives me a negative. And then we plug in probably 0. We like to plug 0 in. And I get a negative over a positive again. So that's going to be negative. A lot of times these functions will switch, right? They go negative, positive, negative, positive. This one didn't do that, so be careful. They don't all do that. And then x equals 3 is a positive over a positive, so that's going to give us a positive. All right, so now we're trying to figure out where this thing is less than or equal to 0. Now, I will have people who will tell me it's less than or equal to 0 from negative infinity to 2. Is that right? No, that's wrong. Okay, you can't include negative 3. Negative 3 is not allowed. So when you write your answer, you have to write negative infinity to negative 3 union negative 3 to positive 2 with a bracket. Okay? I really like this. I don't think I've ever done it this way until this year, but I really like doing that open circle there just to, you know, a reminder to yourself. Now, I graphed this thing earlier in first period, so let me show you what this looks like graphically. Okay? The question is, where is this thing less than or equal to 0? So the graph looks like this. It goes like this, okay? Because at negative 3, what is that? Asymptote. And then it goes like this, okay? So right at 2, that's where it's above. Everything else is below. Okay, do you see that visually? It's really good. All right.